Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled NGC 300, a cosmic gemstone with stars and gas clouds. So what do we see here? Well, this is an example of a spiral galaxy, and you may note that it doesn't look a lot like the typical spiral galaxies that we see. And that's because of the way the image is taken. And in fact, it's taken looking at three specific colors of three elements that are shown here. So we're looking at emission of sulfur in the red, hydrogen in green, and oxygen in blue. So we look through three different filters looking at each of these different elements and then combine their light together to get a single image. So areas that look blue tend to be showing emission of oxygen gas. Areas that look greener are showing hydrogen gas, and areas that look red are showing sulfur gas. Now, depending on how those combine together can give us other colors like the yellows or oranges that we see throughout a lot of the image. It's not that those are different, it's just that we're seeing different combinations of the red, green, and blue colors that were used to generate the image. Now, what this does when we look at those specific wavelengths is we're highlighting the gas within the galaxy. It is gases that are energized that give off specific wavelengths. Stars themselves give off a broad spectrum, so they emit light at all wavelengths. And therefore, when we look at the light through these filters, we are emphasizing the gas over the stars. Yes, we're getting some starlight, and we see plenty of stars in this image. But we are emphasizing the gas because it is gas that we're looking at all of their light, and with the stars, we're just looking at tiny portions of their light. So that's why we see all of these bubbles of star-forming regions scattered around this galaxy. Now, the stars that form within these tend to be very hot, massive stars. Those are the first stars to form, and they are the ones that can energize the gas. In order to do that, you need ultraviolet light. Most stars don't give off a lot of ultraviolet light. Our sun does give off some, but it primarily emits in the visible portion of the spectrum. These hotter stars give off more energetic light and do give off a lot of ultraviolet. That is what is needed to excite these gases and cause them to glow. So when we look at the wavelengths of those three specific gases, that's what we're highlighting here. Now, these stars, these massive stars, don't live a very long time, talking millions of years typically, and they are going to eventually end their lives as a supernova explosion. So many of these gas clouds could be hiding supernovae that have already occurred that we may not even be able to see, simply because there's too much material between us and the star that exploded. In some cases, yes, we would be able to see them. In others, they could remain completely hidden to us, even such a massive explosion as a supernova. And in fact, this galaxy at about 6 million light years away means that if we see a star explode in it right now, that would mean it actually went off 6 million years ago. So any stars that have become supernovae in those last 6 million years, we're still waiting. We are waiting the time it takes light to travel that immense distance to reach us here on Earth. So that was our picture of the day, titled NGC 300, a cosmic gemstone with stars and gas clouds. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.